All right, so this is a pretty unique problem involving the sign test. You'll notice, you may not know already that it's the sign test that we're performing here, but we'll notice here that for most problems we use StackCrunch to complete the work, but unfortunately StackCrunch for non-parametric distributions, which we're covering in this chapter, that non-parametric distributions, you need raw data. In this case, we only have summarized data where it has the amount that's less than 1225, greater than 1225, and equal to 1225. So there isn't any raw data here. And we'll actually notice here that we really can't use use StackCrunch either way for the sign test. They're the different procedure that we'll have to use, and we'll go over that now. So for the most part, we have to do this by hand. Let's take a look at this, and I'll break it down for you and to show you how we would work through this. So for part A, we want to write the claim mathematically and identify H naught and H alternative. Or the null and alternative hypothesis. And they first asked for the claim. So the claim here, in this case, the claim is stated in the first sentence. A labor organization estimates the median hourly earnings of male workers paid hourly rates is 1225. So is 1225 is the claim, and so that's equal to 1225. So that's the median is equal to 1225, as mentioned in the first sentence. Okay, and since it says that it is 1225, then that means we have a two-tailed test, and that's why we choose D for null and alternative. That's the one that has the two-tailed test set up. And determine the critical value. Now, to be able to do this, we need to, since we're doing the sign test, we have to look at the sample size. So let's look at the textbook really quickly. So for a sign test, it's mentioned on page 585. In determining which way we go about this, we want to look at the sample size. This is for test statistic, but this also applies for the critical value too, as we'll see. I'll point out in a moment. So when n is less than or equal to 25, we use the procedure that's mentioned here, and we use the smaller of plus or minus signs. And when n is greater than 25, we use a more structured method that's more accurate because we have a larger sample size, and it's a different procedure. And for the sign test, it follows a standard normal distribution. So we're dealing with the normal distribution when we have n greater than 25, and we use this equation. So the sample size is defined in an interesting way. Well, we have to do a little bit of preliminary work. It's not that difficult, so we just need to look really quickly to see if we have less than or equal to 25 or greater than 25. So what we want to look at is how many total values, occurrences that is less than and more than 1225. We ignore the equal to 1225. As you can see, 3 are paid 1225 per hour. We want to ignore the ones that are exactly 1225. So the 3 we ignore. So notice that 11 is less than 1225. So those are the negatives, less than. And then 36 are paid more than 1225. So that's a total of 11 plus 36 that are either negative or positive. So that's a total of 47. So that is considered a sample size. Again, we ignore the ones that are equal to 1225, neutral values. We ignore those and only look at the negative and positives. So in this case, n, based on the criteria we're looking at here, is 47. So that is greater than 25. Since n is greater than 25, we're using this procedure, and we were following a normal distribution. Okay, so we'll get back to the test statistic, which is this equation right here. But we are following a normal distribution, so that helps us with our critical value. So to determine the critical value, a critical value that has alpha equals 0.05, we could actually use StatCrunch for this, but that is a very common standard normal value, like a z-value. So anyways, so we would want to look at, let's see here, the standard normal distribution, and at alpha equals 0.05, and we know that that would be equal to negative 1.96. And I'll show you on the calculator really quickly. StatCrunch. Now, typically we would have, actually, I'll mention in a second. Let's look at this data. No, wait, stat, calculators, and normal. And we want between, and we want the between value to be 0.95 because, and that would give us negative 1.96 and 1.96. But here's the thing. When we have a when we're dealing with the a sign test, we're only looking at the negative value, negative 1.96. Now, hold on one moment while we look this up. I'll actually show you where it's mentioned in the textbook. Just one moment. So the reason that the critical value is negative, it's actually we can actually tell why that's true based off of this test statistic value. So notice that x is the smaller number of plus or minus signs. So we'll always notice that x plus 0.5 minus 0.5 times n, which is the sum of the plus and minus signs. You'll always notice that this value in the numerator will always be negative, and then the bottom number is always going to be positive. So z will always be a negative number. Now, how large in the negative direction z is will all depend on how far the plus or minus signs are away from each other. So the further out the z is away from 0 in the negative direction, the more critical the more extreme the value is, which will lead to a rejection if it's too far out. So that is why we're only looking at a critical value in the negative direction, because we'll never be in the positive direction. So even though it is two-tail, we're only looking at the negative critical value for a sign test. So anyways, looking at that, or keeping that in mind, that is why we only have the negative 1.96 and not the 1.96, is because the test statistic is always negative. Okay, so it may not be that obvious that the test statistic is always negative, but just kind of play with some of the numbers and you'll realize that numerator for the test statistic will always be negative. Let's go ahead and calculate the test statistic. We're done with the critical value. The test statistic we have to do by hand, since we're not since we are given summarized values and not the raw data. So let's go ahead and look at the formula. So here's the formula. I'm going to move this over a little bit and pull up this screen here. Oh, let's go ahead and I'm going to pull this up a little bit higher, get it out of the way, and I'll write down the formula. Okay, so we have, for when, since n is greater than 25, since we have n equals 47, since n is equal to 47, which is greater than 25, then we're using the z equals x plus 0.5 minus 0.5n over the square root of n divided by 2. Okay, so, and x is the smaller number of plus or minus signs. So x is smaller number of plus or minus signs. Oops. Signs. So let's figure out what x is equal to. Again, we already have n equals 47, so we'll be using that in this formula. But in this case, x is the smaller number. So let's pull up this information. So the smaller of the plus or minus, in a sample size of 50, 11 pay less, and then 36 pay more. So 11 is our x value, since it's the smaller between 11 and 36. So let's pull that up. So x is 11. So let's plug in those values. So we have 11 plus 0.5 minus 0.5, and n is 47. And as you can see, since we're using the smaller of the plus or minus here, and we're subtracting half of the total of plus or minuses, this will always be larger than this. So this is always larger, and this is smaller. So we can see an example of what I mentioned before. Smaller minus a larger is always going to be negative. So that's why the numerator is always negative, because we're taking a smaller and subtracting a larger. And then the denominator is always positive, because we're taking the square root of 40, in this case 47, or n, and we're dividing that by 2. So anyways, as you can see, z is always negative. And so doing the calculations, let's finish that up actually down here. I'm running out of room. So 11 plus 0.5 is 11.5 minus 0.5 times 47, which is 23.5. So minus 23.5. As you can see, smaller minus larger here. And then we have the square root of 47 divided by 2. I'm going to go ahead and calculate that here. Square root of 47, and then divide that by 2. So make sure that you close parentheses on the 47 and then divide by 2. That gives me 3.428. And let's keep going. Approximately 3.428. And 11.5 minus 23.5 is negative 12 over 3.428. And divide that by 3.428, the negative 12, and that gives me approximately negative 3.5. And 0.006. Let's see how accurate they want our solution. So this is the test statistic here. We'll see how we want to round this. Calculate the test statistic, and they rounded the nearest hundredth to the 2 decimal places, and we had negative 3.5006. 2 decimals, that would be negative 3.50. And so that's why they get the solution they did. Okay, decide whether to reject or fail to reject the null hypothesis. And since the test statistic is further away from 0, this is how we deal with normal distributions. Since the test statistic is essentially in the critical region, because it's less than negative 1.96, we reject the null hypothesis, and then we state our conclusion. All right, that's a bit of a lengthy problem. Had some explanation involved there, but let me know if you have any other concerns.